皆様、お時間になりましたので、スタートしたいと思います。テリロジーワークスの宮村と申します。本日のテーマはですね、今非常に課題となっている、ソフトウェアのサプライチェーンに対する攻撃というテーマで、フランスのGitGuardian社の方からですね、現状についての課題、事例、対策等のお話をしていただく予定です。なお、GitGuardian社のツールそのものについてのご紹介というのは今日はあまりありませんので、もしそちらの方にご興味ある場合にはですね、また別途お問い合わせをいただければというふうに思います。
So, I'll give a brief introduction of GitGuardian before handing over to Mackenzie.
Sure.
So, we are a French company exclusively focused on automated secrets detection technology. And to be clear, by secrets, I'm referring to things like API keys, database credentials, certificates, usernames, passwords, and much, much more. And these types of secrets are used more and more and are sensitive because they can give access to things like servers, databases, payment systems, file systems, and more than that. And another way to describe the problem that GitGuardian is trying to solve is secret sprawl, which is the phenomenon where we see that these secrets are spreading within companies' internal systems. And so we have two solutions to help solve this problem. So our first solution is called public monitoring, and this helps keep an eye on the public activity that is found on public repositories on GitHub for potential leaks that are connected to companies. And our other solution is called internal monitoring. And for this solution, we're looking internally at private repositories and other places in for example, the CI/CD pipeline or even messaging systems to find secrets from within and to stop them becoming a risk. So we're tackling secret sprawl from within in this situation. So I'll hand it over to Mackenzie, who will take it over from here.
Hello, everyone. It's great to be able to present to you today. So I'm going to be talking about supply chain attacks in particular, and how hackers are able to penetrate into the supply chain to attack your or multiple organizations. So I think the first place to start is, what is a supply chain attack? And essentially, it can be defined as a technique where an adversary, in this case, a hacker, slips malicious code or even a malicious component into a piece of software or hardware. So this has really become a big problem when we consider the modern applications and how we build software today. So modern applications use hundreds and sometimes thousands of different components and building blocks to make up their application. And this can be SaaS applications, managed services, and also open source software components. Some estimates bring it upwards of 90% of applications today are made up of different open source components. So this can actually mean that the hackers or the malicious actors know your application's source code better than you do because they analyze these open source software components for vulnerabilities. So today, I'm going to be focusing on a smaller area of the supply chain attack. It can affect hardware, software, services, and people, but I'm going to be focusing on how attackers really target software and services within an application to run an exploit. So to just use an example of really how this happens is that you have an application that itself has dependencies. These can be the open source software or services that we just spoke about. And these dependencies within your application can also, and often do, have dependencies on their own. And why this is so scary is that if you have a dependency that has a dependency which gets compromised by a hacker, it can trigger a chain reaction from the dependency of the dependency to the dependency all the way through to your application. And just to illustrate how big of a problem supply chain attacks have become in the recent years, we can see that this year the White House in America issued an executive order on improving the nation's cybersecurity. And this was in response to the SolarWinds attack, which we've all heard a lot about, and a huge number of other attacks. A big part of that bill was specifically about supply chain software security. And this is all proves how much of a problem this has become in recent years. And the problem, unfortunately, is only growing and getting larger. So I want to run through some real-life examples of supply chain attacks and how they happened. And then later, we'll talk about methods that organizations or yourself can do to prevent these types of attacks. So the first incident is one that involves an open source component that was very popular. It was a package called Event Stream. And what this graph shows down the bottom is that this package was very well maintained for the first few years. But then since around 2013, it's had very, very little updates, which means that the package really had began to decline in maintenance help. And what actually happened was a malicious user started maintaining this package. And he added a dependency within EventStream called FlatMap. And while this was not malicious at the start, what ended up happening was that that new dependency, FlatMap, was turned into a backdoor attack target. And because the FlatMap was in the event stream, it actually added a backdoor into all of the applications that were relying on this dependencies. And EventStream was actually downloaded 8 million times while this backdoor was in place. And so all of those applications, those 8 million applications, would have been completely unaware that there was actually a backdoor into their applications coming from the EventStream package they were using. And this itself isn't a new or a unique problem. In fact, this happens all the time. And almost an absolutely identical attack happened on a different package called Electron Native Notify. So these two examples really just illustrate how dangerous and problematic it is with how we build applications today. But it's not just limited to these open source components. Hackers are also targeting services that we use within our application. Thanks to the introduction of CI/CD pipelines, we're able to really increase the rate of which we can deploy and update our applications today. But these CI/CD pipelines have become the perfect target for attackers today. And that largely is because within particularly the CI pipeline, you have a lot of access to sensitive information, to code repositories. And if attackers can penetrate into a service within that, then they can target multiple organizations and applications. So I want to run through one example of a supply chain attack within this CI environment, and that is the example of the CodeCov attack that happened this year. So CodeCov is a relatively unsuspecting service for users. Essentially, it is a code coverage tool, which means it checks how much of your application is being tested. Now, this doesn't scream out that it would be a really high value target for attackers, which is actually what the attackers really relied on to conduct this breach and this attack. So what actually happened in this breach was attackers were able to extract secrets for a Git repository from the way that they created their Docker image. So once the attackers had access to the Git repository, they posed as employees of CodeCov and inserted a malicious segment of code. So the file that they actually compromised is this file here. It is a bash uploader script, and it is thousands of lines of code. It is very difficult to spot anything within it. But there is one line of code in here that is malicious. So this one line that I've highlighted here is very unsuspecting. It's very easily to hide it within this large file. And what this does is it takes the environment variables from the CI pipeline and it sends them to the attacker's personal server. And with that one line of code, they will be able to exfiltrate the secrets within that CI environment of 23,000 customers using CodeCov at the time. And this was undetected for nearly 3 months whilst the attackers were able to penetrate into multiple different organizations. But what is interesting about this is actually what the hackers targeted. What they were specifically trying to do is gain access into the private code repositories of the customers using CodeCov. And this is because private code repositories, private Git repositories, are known to be very high value targets for attackers because they contain so much sensitive information today. And even though we may know that we shouldn't put private information in our Git repositories, it still happens amongst even the largest companies in the world. This breach affected the likes of Twilio, Rapid7, and Mercari. So this really shows that it's not small organizations that are only affected by this. Supply chain attacks can affect everyone from a from a small startup all the way through to massive organizations. But now let's talk about why Git repositories specifically were the target in this attack and why Git repositories are increasingly becoming the target in multiple supply chain style attacks. One of the interesting things about Git is that it keeps a copy of everything that we do. And as this graph shows, the additions are in green and the deletions are in red. We delete just as much code in our repositories as we add. And this means that the amount of information and potentially harmful, sensitive information within our Git repositories is much greater than what we just see on the surface. And attackers really rely on this to be able to find sensitive information hidden in the history. This can include secrets, what Ramsey was talking about, but it can also include personal information or insights into how your application is put together. So let's look at how big the problem of sensitive information is within Git repositories. Last year, GitGuardian scanned every single public code repository on GitHub. In total, we scanned over 1 billion commits throughout that year. And we ended up finding over 2 million secrets throughout that year, or 5,000 secrets every single day. Now, this was an increase on previous years, but what it shows is the amount of sensitive information that is buried within our Git repositories and hard-coded into our source code. And remember, this is public repositories. So now you can understand why the private code repositories, which will contain much more sensitive information, is such a high-value target for these attackers. So let's talk a little bit about securing our supply chain. How can we prevent these styles of attacks in the future? These types of attacks are almost impossible to prevent completely. And this is because of what we have control over. We have control over our application. We have some control over the dependencies that we have, but we have absolutely no control over the dependencies that they use. So when we're talking about securing our supply chain, there's some things that we can do, but ultimately we need to focus on what we can control. That is not preventing a supply chain attack, but limiting the damage that one could do. So we have control over our Git repositories and what is inside of them. We have control over the access of our infrastructure. We can segment our services so that if one is infiltrated, it doesn't create a chain reaction onto all of our services. And we also have control over the data and personal information and how we store it. And we also have some control over the immediate dependencies that we use. We can scan these for known vulnerabilities and make sure we update them regularly. And we can validate our dependencies against using hash functions to make sure that we have the correct packages. So let's just touch on a few of those and elaborate a little bit further with actionable things that you can do to secure these processes. So with our code repositories, we can make sure that there are no secret and no sensitive information within these. A good exercise is to imagine if your source code was open source tomorrow, would there be any security breaches because of that? And if we use this standard for our private code repositories, then if an attacker gains access to it, the damage that he or she can do is very, very limited. Then we can look at securing our application. We can segment all our services and make sure that there are stop checks in place to prevent an attacker from moving laterally through our services. We can also limit the scope of our services, so making sure that we don't have read-write access when read access only would be enough. And we can also monitor the traffic within our application and set up alerts so that if something suspicious is happening, we get notified about it immediately. And then with our dependencies, we can implement some checks to make sure that these are as secure as possible. This includes making sure that we don't use dependencies that aren't well maintained or have not been maintained for some period of time. We should regularly update and patch our dependencies, as well as scanning them for known vulnerabilities. And when we're looking at the services that we use, we can also ask questions about their policies that they have in place, about what they do to prevent supply chain attacks. And this is actually becoming somewhat easier now, as the software bill of materials, or SBOM as it's shortened to, is actually starting to become a reality. And what an SBOM is essentially a list of ingredients that make that application or service run. So soon you'll be able to look at the services that you use and with open transparency, be able to see if they are using any dependencies that might be vulnerable themselves. And this is actually a great initiative. For a long time, we wanted this type of change to happen. But in the White House executive order I showed at the start of the presentation, part of that is mandating the software bill of materials for certain software providers. So as we approach the end of the presentation, I want to leave with the final closing notes that software supply chains cannot be completely prevented, but the damage that is done from them can be. And we shouldn't change the way that we build applications because of this threat, but we need to be aware of it so that we can build our applications more securely with these type of attacks in mind. And if you want to learn more about GitGuardian and how we can help prevent these supply chain attacks or the damage that they do, there's some great useful material on the GitGuardian website.
で、今日ここまでのお話について、もし何かご質問等ある方はですね、今いただければというふうに思います。一つ今ご質問いただきましたので、ちょっと聞いてみたいというふうに思います。We actually have one question, and this kind of cyber attack targeting, this CI/CD the pipeline. When you have noticed that this kind of attack increased, and if you have any kind of information or statistics about such incidents of attack. Would you please share with us?
Yeah, there's lots of statistics kind of coming out of these. The problem with a lot of these this style of attacks is that they go unnoticed for so long, and it's very hard to quantify, to put a number to the damage that it's had.
I see. In terms of their kind of timeline, do you feel or do you see any kind of the sign you have initially noticed that this is a really big issue?
So supply chain attacks over the last 2 years have really become very prevalent. The big catalyst from this has been the massive success of such attacks. So for instance, the SolarWinds attack was one which really led the charge on this style of attack. Whilst they have always been around, supply chain attacks have always happened. The introduction of how we build applications today has made them much more powerful. So there has been a steady increase of these types of attacks over the last 5 years, but in the last 2 years in particular, because of the success of other attacks, they have really increased.
All right, one more question is that from their IT security management perspective, like an InfoSec team, probably they do not have clear visibility on how developers are using this kind of environment. And there can be some gap between the InfoSec team and the actual developers. So from InfoSec team perspective, what they should learn first to prevent this kind of attack?
So the most important part is understanding all of the systems that the developers use. I don't feel that it is necessary that everyone has to learn everything about everyone's job. As an InfoSec member, you don't need to know how to code specifically, but you need to understand how the applications are put together. So the first steps in preventing these types of attacks is about knowing the systems that they use and being able to identify how attackers use this to their advantage. And just again on that, what is really important is the collaboration between developers and InfoSec teams and all the teams within the organization. It's really important that you are able to share your knowledge with the developers because you as an InfoSec team have interesting insights. And in return, the developers need to share that with you. There's a collaboration that needs to happen. It's not 100% any one person's job. It's everyone's shared responsibility.
All right, Ramsey and Mackenzie, thank you very much for the presentation. It was quite informative. Thank you very much, educational. And we are also developing the software in-house and sell the software to our clients. So this is really something serious for us too. And thank you very much for sharing your insight. And we will enhance our own, software development activity and put some framework to it. Thank you very much.